Hello everyone and welcome to the second part of the mineral processing flowsheet tutorial. In this tutorial we will go through how to set up the parameters and stream connections inside the unit operations. First, let's take a general look how the model and the unit editor actually looks. So we can see that this editor is quite a bit different than what we saw in the reactions and in the distributions. All of the particle unit operation models look like something like this. They have the navigation bar over here and then some tools over here. And these are the so-called DLL models. You can also create these DLL models by yourself if you know how to program, but that is not covered in this tutorial yet. So here on the left we have the usual input-output information of the streams that come inside the unit. In this case they contain a lot of particle size related information and also mineral processing related information. Then we have the model parameters, which I can filter by pressing here settings or bond equation. And then we have runtime values here, which tell some calculations and variables that are calculated during the runs and when we simulate the model. One very important thing in these DLL models is this stream connections tool. So in the stream connections tool we map the streams that we draw in the flowsheet to predefined ports inside the unit. So in this ball mill model, the one who created this ball mill DLL model defined these two inputs here. And now when we draw the flowsheet, then these input streams are automatically assigned somehow here in the input ports. And if I want to change from one port to another, I can put it here and then transfer it to some other port. But in this case I want all my feeds to be in the mill feed box, so that looks good. And then the same works also for the outputs, and in here we have only the discharge and one stream coming out of the unit. But it's a good idea every time you make a model where you use these particle size models or DLL models, it's important that you check these stream connections for each unit so that these streams are mapped correctly. Here we can also see that we have two types of ports in the input side. We have this colored and non-colored port. This mill feed, this is the normal type of port, so it means that all the streams connected here bring actually the material and energy from their stream to this unit. However, this colored box here in the circuit feed means that in here we only insert the reference of a stream, but it doesn't actually bring any material or energy through the selected stream here. So if I click here and now we want it to be circuit feed, which in our case is the OR feed. I click here, I can see that the stream comes here and as a reference, and now we have the corresponding reference here in the colored box. As you can see, the stream reference has this optional field over here, which means that it is optional to insert this reference here. It might be used in some calculations or not. It depends on how the DLL unit is made. And as for this unit, we won't go into too much detail about that. Okay, so now we have gotten familiar with the tools in our unit editor over here. So now we can start to define the actual models. So first to the ball mill, I double click to the ball mill and I have some default values here. Let's see if they match the values that were specified here. Ball mill, P80 target. Okay, that seems to be correct. And as for the ball mill discharge solids percentage, we need to make a control. So we make a control here, solids percentage, and it's going to be percentage, and we want it to be 65, and we measure it from the output sheet, ball mill discharge, solids percentage, copy cell reference, and paste cell reference over here. Then we will control it with the ball mill water feed. So I will write it here. And the measurement unit is tons per hour. And for this reference, there is a special way to get this reference. Since the stream setup is currently in this version not yet shown as an Excel, so I can just go here and get the reference from here. So if I want the liquid flow rate reference, I press here. If I want the solids flow rate reference, I press here. Now I want the liquid, I press here and update and close. And then here, right click, paste cell reference, and it will come here. I will put the max limit a little bit higher. And that's it. We have now defined the control for our ball mill. And also these other parameters. Next, let's check the sump. So if I double click here, I can see that we have perfect mixer model here. And this is a very simple model. So it only mixes everything that comes in from these streams into streams in the output, and now we have only one output stream in the outputs port. So now all the inputs go into this stream. So that's it. Next we go to the hydrocyclone. I double click here. First I check the stream connections again. Feed, okay, grinded ore coming here. How about the outputs? So we have the hydrocyclone overflow for the fine and hydrocyclone underflow going to the coarse, and that seems okay. Then we go here to the parameters and we check hydrocyclone corrected 50% cut size, 70 micrometers. So we change that value here. We don't adjust the other values. And then for the controls, since we had hydrocyclone overflow solids percentage is controlled with a pump sump water feed, so we make again a solids percentage control here. And we want this to be 35, and we measure it from the output cyclone overflow solids percentage, copy cell reference and paste cell reference here. Then we control it with the pump sump water feed. So I write it there, and again, because this reference is from stream setup, I have to go to the stream setup first. Now I can double click since it is already made here, and then get the reference here, update, and then paste it here. And then I adjust it a little bit higher, maximum value, and okay. So now our hydrocyclone model is ready. Sometimes it's a good idea to calculate your model even though you haven't finished all the models here. For example, we haven't finished these two yet, but we might want to see how the flowsheet calculates with our current parameters. So let's see, we run the calculations and wait for the calculations to go. Now probably because the controls are calculated the first time in here and in here, and we have external controls, the calculations can take a little bit while at first. Let's see what kind of results we get. Okay, here everything seems fine, and if I go now and look here, the solids percentage control is at least fine. And how about here? Hydrocyclone seems to be fine. Okay, everything seems to be correct in our model, so we continue to defining the conditioner and flotation cell. So first let's start with the conditioner. So the conditioner unit operation model sets the kinetic parameters for all the particles that come inside the conditioner unit. So in this case, all the particles that come with the hydrocyclone overflow have their kinetic parameters set in here according to the model we select here. So as with the other units, first I check the stream connections and I can see that the fresh feed, okay, hydrocyclone overflow, that's correct. We have an optional recycled feed, but we don't have any recycled feed in this case, so it's correctly empty. And here we have only one output, so this is fine. Then we set the correct flotation model, and now it's set to rectangular distribution by default, and that's what we want to use. Then we get the kinetic parameters for each size, class, and mineral, and we have those here in the tables, so I will copy them here, copy, and then paste over here, and then I just copy these zeros to the bigger size classes because they don't float. Okay, that's for the R, and then for the K, I open up another table editor of that table, and then I copy these values here, copy, and then paste them here over here, and then again I put the zeros to the bigger ones. Okay, now we have the kinetic parameter set in the conditioner. Finally, we will check the flotation cell. So if we double click here, go to stream connections, then we can see that in the inputs the conditioner output is connected to the feed port, and that's correct. In the outputs the tails stream is connected to the tails port and concentrate to the concentrate, so that's fine. We have a lot of parameters here that we can adjust, but in this case there was no specification about them, so we just leave them as they are. And now our model should be ready. So we calculate a few times again. And let's see what kind of results we get. Okay, and if we go to the flotation cell, we go to the output, we can compare the tails and concentrate streams over here, and we can see that the copper weight percentage, for example, in the concentrate much bigger. We have much bigger total solids amount here than in the concentrate, and also we have a lot of chalcopyrite in the concentrate, as it should be. So it seems that our flow sheet is now reasonable, and it works as according to the specifications. So now you should be able to use the mineral processing and particle size based unit operation models that we have in the library here, this list, and also you should be able to use the stream setup to define particle size distribution stream and mineral stream and create flow sheets using those tools. This concludes the mineral processing tutorial. Thank you for watching.